Hello, Nordic API. Yeah, my name is Francois Lascelles. I'm in the office of the CTO at Ping Identity. And I look at API security for Ping Identity. I've been doing API security for many, many years. So today's talk is about mining API traffic metadata. So what am I talking about? What is this API traffic metadata? So what I mean by API traffic metadata is this. So you've got HTTP traffic between API client, which I will refer in this talk often as apps, and API endpoints. And by looking at this API traffic, you can get data out of this. So which resource is being called? Which token, if any, is present? Which cookies? It's weird to me, but in some cases, some APIs have cookies in them. Where is it coming from on the network location? How big are the requests, the responses, the latency? How long does it take for downstream for your API endpoint to respond? The content type coming in, going out, errors. By the way, the last talk on HTTP errors was awesome. And then API traffic metadata to me is over time looking at trends around these attributes about your API traffic, like the sequence per token, per API key, and things like that, how many calls, and things like that. So that's what I mean by API traffic metadata. Who cares? Why am I talking about this? Well, I would like to suggest that API traffic metadata is the key to addressing two problems. One is an API visibility gap, and the second is an API security gap. So in this presentation, I will go through each of these two problems. So in the first half of my presentation, I will describe the problem, and in the second half, I will go back and talk about how API traffic metadata is addressing each of these problems, starting with the visibility gap. So very often, we talk to organizations about APIs, and I used to sell API management. And you would ask somebody, tell me about your APIs. What kind of APIs do you guys have? And they would say, oh, we don't have APIs. And like, oh, that's weird. Like could be a bank, for example. How does this app work? I've got your app on my phone. Oh, I don't know, but I'll find out. And they find out. So yeah, there's kind of an API in there, but it's private. Nobody knows about this. It's not really an API. And I think that is the most dangerous thing. An API doesn't need to be public for an API to be an API. So if you consider an API to be an implementation detail, right? So only 2 Scrum teams know about this API, that is problematic. And I don't know if you noticed, but last month, Gartner released a fresh report on API security. And one of their top recommendations was to discover your APIs before attackers discover them. And I think that's exactly the kind of stuff that they're thinking about. Another name that I have for the implementation detail is shadow APIs. APIs that are not known from a security perspective to people who should be responsible to scrutinize the APIs. So that's one of the reasons why there's a visibility gap when it comes to APIs in many organizations. And another reason is the old forgotten versions. Right, we're almost in 2020 now, and APIs that we've been working on. A lot of you guys in this room have been working on APIs. These APIs have evolved over time, and they've gone through revisions. And very often, you release a new version of an API, and you need to keep that older version behind just because there's some backward compatibility issue with a specific client, and then that gets resolved, but it's still there, it stays behind, you forget about it. So what it comes down to is that a lot of security organizations are not confident that they know about all the APIs that they're effectively exposing. So there's a blind spot about APIs that are not on your radar today. Another blind spot is caused by what I call API silos. So again, we're in 2020, and we've gone through a couple of revisions, some of us, for implementing API stacks, right? So you might have some stuff on Apogee, you might have some stuff on Axway, maybe you've gone through an acquisition, you're using different stacks that implement APIs. And each of these stacks will have their own security procedures, and those are not necessarily consistent. You will get different types of visibility from each of these stacks. These won't be consistent. So that's what I mean by the visibility gap. Now let's talk about a security gap. So securing APIs is not simple. There's a lot of things that, and I think a lot of breaches that we regularly see are a testament to the fact that, and I'm not sure if it was Mark O'Neill or that said, everybody has a WAF and an API gateway, and everybody still gets hacked, right? And I think one of the things to keep in mind, and that touches back on what I was saying earlier about the implementation detail, is that hackers know about your APIs, right? Your API is either well documented because it's public, and if it's not, then it's easily reverse engineered. One of our customers is using, as an analogy, a hacker, decapitating an app, a client-side app, and then looking inside and figuring out how the API is being called. So this is easily reverse engineered. If your API can be called from a browser app, you've got your browser tools, you can see exactly what goes over the wire. If you're using a native app on a mobile phone, for example, if you don't have proper cert pinning, you can pass it through a forward proxy and find out everything that you need to know about the API. And hackers use your API outside of your client-side app. And that's a problem because when you're using an API outside the client-side app, all of the client-side rules, which shouldn't have anything to do with security, but it doesn't matter, you're skipping all these rules, and if you're not testing security at the API level, if your security is going end-to-end and always going through your client-side app, once you're skipping the application, you end up in an untested for API abuse scenario. So hackers have the freedom to poke around and find vulnerabilities that they can then exploit. So that's another blind spot. And on the server side, you can't tell the difference between API calls coming from, let's say, your app that you're publishing and just any other application, right? And people have been trying for years to solve that problem, right? People have been putting API keys in the client applications, hoping that, okay, now I know that this is coming from my app. It doesn't work like that, right? There's some really weird use cases where you can tell that it's coming from your client. Maybe you've got a workforce scenario where you've got a secure device and you've got a private app store, and the only way to provision this app is going through your IT department. Sure, in that case, I guess you can tell that your API calls are coming from your app. But otherwise, you really can't tell the difference. And I think, if you're looking at a lot of breaches that have been happening, and I've got a sample here from some of the more famous ones. One of the things that they do have in common is that it takes months, if not years, for these breaches to be detected. And to me, that's just another way of saying that they're not detected. The API provider finds out that there was a vulnerability, maybe because a user complained that their identity was stolen, and they figured out that it was coming from that service. Or maybe a hacker is demanding a ransom, and then you look into it and say, oh, oops, look, there's a problem there. So this leads me to talk about persisting API security gaps. And I categorize those under two categories. The first is the foundational API security blind spot. So I've talked about unexpected outside the app scenarios. There's a deficit of available human expertise, right? There's a lot of very sophisticated tooling that allows you to do API security, but that sophisticated tooling requires sophisticated humans, right? Those are people that need to know about your APIs, they need to know about your application, they need to understand security, they need to understand how your infrastructure works. And these people are rare, and you're probably thinking of who these people are in your respective organizations. Those are the people that people always say, well, I wish I could clone Susan, or I wish I could clone Joe, right? There's a deficit of these experts, and the result is that you are very often not getting maximum value out of those sophisticated security tools. And then finally, things like API gateways have a real-time security focus. An API call comes in, you have to take a look and decide, should I let this through or not, right? These are real-time security decisions, and you can't stop certain attacks with that approach. So that's one category of persisting API security gaps. The other one is the external vulnerabilities. I would argue it's not fair to blame the API on these things, but there's still API security problems. So downstream vulnerabilities, bugs downstream in an API endpoint. Users that are gullible, they can be tricked into phishing. Password reuse, that's the user's fault. Insider threat is on the rise, right? You have a token, you validate the token, it's a valid token, it's a valid user, but hackers are users too, right? And then clients that can't keep secrets. Earlier this year, there was that study that showed how many, I think it was in the hundreds of thousands of client-side secrets like API keys and tokens that could be mined out of GitHub, right? That's a great example. You can't trust client-side applications to keep secrets. You shouldn't trust them. And then bearer tokens. Unfortunately, right now, most API security implementations use bearer tokens. There's very little signatures happening right now. So if I drop my token on my way to the train and you pick it up, you can impersonate me, right? So you can't protect yourself from those kinds of threats using what I call foundational API security. So how are you supposed to mitigate these persisting vulnerabilities? So I've described an API visibility gap, a security gap. Now let's talk about how API traffic metadata is going to help you address these two problems. Starting with the visibility gap. So typically, your API governance, your API management is providing to you an API catalog, right? Those are APIs that you've acknowledged and that are, added to a catalog. Those are not effective APIs. If you're looking at your API traffic and you're listing what you see, you're getting what I call effective APIs, a list of APIs based on what you're seeing on the network. And that's very often will produce a different list of APIs. And if nothing else, it's very interesting to compare those two lists. So by collecting API metadata across your API silos, you get an aggregate view of your APIs. So Ping Identity has something called Ping Intelligence for APIs, and it integrates with all the major API gateways out there. You can hook it up to any of those API gateways. You can hook it up to a load balancer like Nginx. You can tap on a cloud front, like an Amazon cloud front or an Azure. So you can tap wide that way. You can even deploy that inline and look at the traffic going through. You can attach it as a service filter. So that's tapping wide. And then tapping deep is about collecting metadata downstream. So maybe directly in your microservices or in your service mesh layer, right? Zero Trust tells us that it's not sufficient to secure APIs at the perimeter. We really need to worry about API traffic beyond the perimeter. So it's important to take a look at your API traffic there. So the way we do that is we have a sideband API that allows to collect API traffic metadata. And I actually created my own microservice filter in Spring Boot. When a new version came out this summer of Ping Intelligence for APIs, I really wanted to tap into this without deploying a gateway. I wanted something lightweight. So I've put that example on a public repo. So you can actually search for Spring Boot filter for Ping Intelligence for APIs if you want to see an example of that. Back to tapping wide, it's important to automate the API discovery. And here's an Nginx example. So on the left, you've got the standard documented way of hooking up Ping Intelligence for APIs in an Nginx configuration. So if you're familiar to Nginx, that's what your Nginx conf would look like. You would add this ASC integration request, ASC integration response. You would wrap your proxy around that, and that would allow for the collection of that metadata. But leveraging inheritance in an Nginx configuration, you can move these out, and then anytime somebody adds a microservice in there, they would automatically inherit the collection of that metadata. If you're using an API gateway, the analog would be, instead of attaching that integration into the service level policy, to use layer 7 language, which is what I'm most familiar with, you would attach it to a global policy, which indiscriminately is going to pull that metadata for you and feed it to that data lake. And here's an example of enriching your metadata with identity correlation, which is something that we started doing with Ping Intelligence for API starting in version 4. So just by looking at this API traffic metadata, we can discover which users, because we can dereference that through the tokens, which users are calling your API. So I can actually now, just by looking at this API traffic metadata, I can get a view for each of my users, which APIs they're calling, which URIs, which tokens have been issued to these users, which IP addresses they're coming from, which methods, and things like that. So by leveraging your API traffic metadata, you can actually enrich this data and get additional insights about it, which is extremely helpful. So I've talked about addressing the visibility gap. Now let's talk about security. So the way that API traffic metadata helps you address the security gap is by analyzing the metadata that you collect. So I was talking about these persisting risks. And what I mean by persisting is that you can minimize these risks by adding better security practices, adding more resources to API level security testing. You can be more strict about how you implement API security, and those risks shrink, but they never completely go away. But by leveraging machine learning, here's what you can do. So the way machine learning works is you take big data, and then you feed it to machine learning, which is going to build a mathematical model for what you're giving it, and then it can make predictions on a new input moving forward. So in this case, the big data is your API traffic metadata. So that's what Ping Intelligence does. It ingests your API traffic metadata. It builds models over time from this data, and this represents a model of what your API traffic looks like, from looking at across all these different dimensions when it's consumed from your legitimate applications, right? And remember what I was saying earlier, that hackers use your APIs outside of your app. And when they do that, it stands out from the model, and that it deviates from the model. So by inspecting your runtime traffic, you can look for deviations from the model, and what you're effectively doing is making a prediction that a token or an IP address or maybe a user identity that you've dereferenced from that API traffic metadata is being used outside of a legitimate application. And because, in our case, we integrate with all these API gateways, once we make that prediction, we can notify, send alerts, so we'll give you back the visibility about the event in progress, but through that connection that we have with those gateways, we can go further and instruct the gateway, the load balancer, the CloudFront, or whatever, to stop accepting requests from a particular token or a particular user identity or an IP address. So API traffic metadata is precious and is underutilized. It provides a better API visibility. So it gives you effective API visibility. It de-silos and give you enriched insights about your APIs. And from a security posture, using machine learning, you can make predictions about an attack in progress, and you can remediate that attack by going back to the gateway and blocking the attack. And even from a legal perspective, legal scholars are talking about metadata as the digital equivalent of DNA with the same power to incriminate. I would speculate that in the future, we as API providers could even be legislated into collecting API traffic metadata for that purpose, and perhaps even make that information open. So that could be something that happens in the future. So I talked about API traffic metadata, and I had this image of this really heavy machinery, which is what mining looks like. But I think it's actually the wrong analogy. I think that API traffic metadata does not require heavy lifting. And I think a better analogy, I grew up in Quebec. My father was a maple farmer. We produce maple syrup. And to me, this is a better analogy. It's beautiful. You just tap the tree at the right time of year. The extra sap flows. All you have to do is boil it at a certain temperature for a certain time, and you get the desired product. I love it. So I'm going to be short 5 minutes here, but in closing, I would like to point to this contest that we initiated recently. So you can win an Arlo camera by trying Ping Intelligence for APIs in order to learn more and discover insights about your API activities. So the URL is there. So I invite you guys to take a look at that, or come see us at the booth. Ping has a booth today and tomorrow. So thank you.
Great. Great talk, Francois. Stay put, though, because we do have a few minutes. So I want to give people a chance to ask questions. I have one if no one else does, but it's a big room of people with questions. Okay, so as we mine the data, Francois, and you exemplified this in the demo you put up there, you end up with sensitive information like tokens and personally identifiable information in there. That's going to lead to security incidents like the Snowden incident, where you have all these BI tools and all the security is removed from that, and someone could just take off with that. Or the private information, and you have someone who wants all of their information deleted according to GDPR. How do you handle that as you're doing that mining to make sure that you're secure and safe from insider attacks and also compliant with regulation? Any tips?
Yeah, I mean, right now, the way that Ping Intelligence works, it's not a service that we host for our customers. It's software that you install yourself, so you are in full control. You're the custodian of that data. So the same way that you would secure and treat your private information for everything else in your system, you would use the same precautions with Ping Intelligence for APIs. Yeah.
Yep.
Obviously, you know, if it becomes a service, or if you want to make that information public or something like that, then you would need to anonymize that. You would need to tokenize the data and have maybe like a vault that would allow you to, you know, get the maximum insights, but control who has access to the underlying data, like the underlying users, the underlying clients, and things like that.
Great, thanks. Did you have a question here?
Hi. So I have a question to this automatic detection of vulnerabilities. So for me, it's not really clear, because I guess you would need a lot of learning data, since I think you can't predict how your API will be used, because an API should be architected in a way that it serves a lot of general use cases, and maybe a lot of them yourself don't even know. So can you maybe elaborate on that a little bit more, how you do that?
Yes. So, yes. What I would say is that, so first of all, the more data that you have, the stronger your model is. So when we build models, we don't just build models around the API itself, but we'll build models around, you know, how a particular user is using an API. You know, what is the sequence of calls for a particular user, how often, when are they using your APIs, and things like that. But you're right, if an API is completely open, and in a case where you've got an API that's meant to be used freely by any developers, and you don't necessarily have control where new applications are coming out, and there's completely new use cases that you may not predict ahead of time or be prepared for, you may end up in a situation where, if that happens after, let's say, 6 months, something comes up with a completely novel use case, you might end up with some false positives or some false negatives, sorry. And which is also true for pretty much any application of machine learning. Sometimes you have to deal with false negatives. So in our case, we have, there's lots of different options, right? So you can, first of all, you can run this in non-blocking mode. So you can add this layer of security in order to look at the predictions that this is generating for you. And very often, that's how people start, right? They just want to see what the engine is finding in terms of deviations, and looking at the predictions that the engine is making. And then once you're comfortable with the fact that you're not seeing false negatives, then you can turn on the blocking mode. But the other thing is that over time, the models continue to evolve. So if you have a novel use case for your API that hasn't been seen before, it may generate some false negatives for a certain period of time, but eventually the model adjusts. And you also have the opportunity as an operator of Ping Intelligence for API, and that was an important thing for us to implement, to do some supervised learning where you will be able to tell the engine, this thing that you predicted is actually legit, and under the hood, Ping Intelligence for APIs is going to adjust the model and adjust the parameters of the model. But it's very legitimate concern, and you should be aware of that for sure, yeah.
Great. Thanks, Francois.
Thank you.